All right, so today's lab, what we're going to do is we're going to generate oxygen, and we're going to collect the oxygen in these big jars over here. We're going to generate it in the Erlenmeyer right here. We're not going to use the manganese dioxide. We're actually going to use iron chloride, but it will create the same reaction with the hydrogen peroxide. The hydrogen peroxide we have stored in this bottle right here. We have 10% hydrogen peroxide. And what we're going to do is, first of all, we're going to go through the setup. The setup for this experiment is a little bit complicated. There's a lot of little moving pieces. I don't have exactly the right pieces here, so I've kind of had to MacGyver and ad hoc it a little bit, but you'll get to see the general setup. So if you look in your book, what you'll see is you'll see an Erlenmeyer attached to a ring stand, which is what we have here. The Erlenmeyer is actually sitting on the bench, so this is a pretty stable setup. And what we're going to do is we're going to put two tubes inside this Erlenmeyer. So the two tubes that we have, as you can see here, look like this. The one, notice, goes all the way down. When I put it in, it's going to be just off the bottom of the Erlenmeyer. I've already sort of calibrated to be so. You can't see that very well, but there's about a 2 mil clearance between the bottom of that one tube and the bottom of the Erlenmeyer. And the other tube, notice, is a lot higher. It's up here. This is going to be our collection point. So what's going to happen is we're going to add hydrogen peroxide through this one that goes to the bottom of the Erlenmeyer. We're going to add it through the top here. I don't actually have a thistle funnel, but this will act in a similar way. And this one here, when oxygen is generated in the reaction at the bottom of this Erlenmeyer, the oxygen is going to stay inside here, and eventually it's going to escape through this longer tube protruding out the top of that rubber stopper. Notice that attached to the end of it is a piece of rubber tubing. We're going to use that. We're going to basically slide it underneath each of these water-filled jars in turn, and as the air collects, it's going to force the water out, and ultimately what it will do is it will allow us to collect the oxygen inside these containers. So how do we get these containers upside down like this? I've already done two. You might be able to see them both. They're kind of like right behind each other right here. I've got a third one over here, which you can see. Here's the third one. So all we do is we basically fill really to the brim of that container. Then we place a glass slide, or in this case I'm using actually a lid to a Petri dish. And then what you do is you're just holding the Petri dish carefully against that system. You can turn it upside down, the water will not come out. We place that in the water and doing our best not to let any air in as we do that. So we did pretty well. They got a tiny amount of air. And I'm just going to slide it off that dish, submerged below the level of the water. And what I effectively do at that point is I create a nice seal so that the water can't get out. Now, really, you should have these, because in this experiment, you see a lot of these falling over. They're usually wider mouth than this, but like I said, I'm kind of working with some limited equipment here. So I'm trying to make this work. So now we have 3 collection bottles that are filled with water. And then we're going to, once the reaction starts, we're going to collect the oxygen inside of these bottles. We're basically just going to lift it over enough to slide this rubber tube underneath it. As the reaction goes, the bubbles will come through, force the water out, and we'll collect the oxygen inside of these bottles. So we have to be careful. We don't want to knock those. If those go over, that's going to be quite a mess. So coming back to the reaction now. So what we're going to do is I'm just going to pull this out so we can set this up. We're going to basically add our iron chloride into the bottom of our Erlenmeyer. So I'm going to add an iron chloride solution. So I have a 0.1 m iron chloride solution, and I'm simply going to add about 50 mils of this into the bottom. I want to make sure I have enough in there to cover the end of that one glass rod that goes to the bottom. I also want to make sure I've got enough for the reaction. So I'm just going to estimate approximately 50 mils. So we probably have just a touch over 50 mils there. And that should be enough for our reaction. So at this point now, we're mostly set up. All we need to do is we're going to add this apparatus on top. If you have glycerin, you can put a little bit of glycerin around the seal here to make it a good seal. I'm just going to carefully press it into place. So I want to try and get a good seal there, so that as gas is produced, it doesn't escape around the outside of this. You can't really tell from the video, but these 2 glass tubes are very snug in these holes in the rubber stopper. We made these specifically this size so that when we're pushing them in, they are They're very tight, so we don't get any gas escaping around the outside. And at this point, all we need to do now is start adding our hydrogen peroxide through here, and that'll start generating oxygen gas in here, and then we'll start the collection by sliding that into each of these vessels in turn. So I'm just going to pause the video here, and I'm going to come back once we've got this reaction fully set up. All right, so we're going to work through setting this reaction up now. So here's the flow of this reaction. We're going to add the hydrogen peroxide from our bottle over here into the top of the thistle top here. We're going to slide this underneath here right before we do that. So we're going to do that now. So we're just tilting the bottle back far enough that I can slide the rubber tube into the opening of the bottle, but we don't let any air in from outside. So that should now be resting underneath that bottle. And hopefully as the air collects, it will collect inside the bottle. So now we're going to start adding the hydrogen peroxide to the thistle. So as we do that, hopefully we'll start to see a reaction. If you look carefully in the bottom, you can see the reaction going. And you can see now in the bottle we're starting to collect bubbles. Those bubbles are the oxygen from the reaction. And then once this container gets filled, we're going to switch it over and we're going to keep doing this until we fill this bottle. So I'm going to leave that in shot because clearly it's filling pretty quickly. All right, so this one's almost full, so the reaction's still going pretty good. So we're probably going to lose a little bit of oxygen as we slide this one off, but that's okay. We're just going to try and collect the gas as fast as we can into the next bottle. And we're just going to keep doing this until we've got 3 filled bottles. And you can see the reaction is pretty vigorous. All right, so that one's full. We're still bubbling away with water here, and we're going to collect the last bottle. And we're almost done collecting the 3. We can still see the reaction is still pretty vigorous. Once we're done, because we don't want to see this shooting out of the top of this thistle here, once we've collected all the oxygen we can, we're going to lift this out so that tube is not in the liquid anymore. So we're going to collect our 3rd bottle here carefully. And once it starts coming up around the bottom like that, it means your bottle is completely full with oxygen. So we can now leave that to go. We're going to keep the reaction going. And then what we're going to do is we're just going to carefully lift this out so that our thistle tube is no longer under the surface of the liquid. Squeeze it out. Okay, now stop. Squeeze it out. Don't let that in. Okay, now stop. Lift it away. All right, so just had to do a little cleanup there. So the 3 bottles are still here. We've taken apart the whole reaction system. So the peroxide that's still in there, you still a little bit of reaction. You might not see there's some small bubbles on the surface. So we're just going to let that continue reacting. We took this apart so we didn't have any pressure building up anywhere. And ultimately that will just vent through our hood here, not a big problem. So now what we need to do is we need to get these 3 bottles of oxygen inverted. So the way we're going to do that is we're simply going to take, you would normally take a glass slide or something. I'm just again using these little Petri dish covers. And all I'm going to do is just slide one underneath it and carefully slide my bottle on top of it, trying to keep a constant pressure on it as I lift it out so I don't lose any air, sorry, any oxygen. Notice how I'm keeping it this way up. I'm okay with the Petri dish being a little bit wet because it actually creates a nice little seal around the lip. So I'm just going to do each of these the same way, keeping a constant pressure on that dish. So again, using it, you can do this with a glass slide. You can do this with glass Petri dishes, it's fine. All you're trying to do is keep it nice and sealed so you don't lose any oxygen out of your vessel. And the reason you do it this way up rather than the other way up is simply because the density of oxygen allows it to stay in the vessel. You might think oxygen is going to come out the top, but in actual fact, I think one of the questions in homework is why do we store it this way? So you need to think through that, and it's related to oxygen itself. So now I can clear this water tray out of the way. It's always good to get water out of the way. As you can see, we create a little bit of a mess with this one, but that's okay. It's self-contained. Now we have the more fun part of the experiment. We have our 3 bottles of oxygen. The question is, how are these different things that we're going to look at be affected? So the first thing we're going to look at is what happens if we put a lighted splint inside one of these reaction vessels. I'm just going to dry my hands off so they're not too wet as we work through these. This is definitely one of the messier reactions, and usually when this happens, at least one group in the lab knocks their bottles of water over, they go all over the floor. So we actually managed to keep this pretty contained, not too bad. So now what we're going to do is we're going to take a match. I'm going to bring one of the bottles forward. I'm going to light the match. Then I'm going to use my match as if it were a lighted splint. So what I'm going to do is I'm going to blow it out and immediately put it in the bottle of oxygen. And there you can see the oxygen relit the match. So in a bottle of oxygen, we can use a heated match like that, and the oxygen in the bottle will actually relight it for us. So there's still a bit of oxygen there. I'm going to keep that. We can do another one in a little bit. And I get to see the cool smoke as it sort of sits inside the bottle there. I'll zoom in a little bit so you can see it a little better. So the first part of the experiment was to take a lighted splint and put it in and see what happened. And you saw exactly what happened when we did that. I'm going to keep this one to the side. The next part of the experiment tells you to take a lighted splint and put it in an empty bottle like that, one where we didn't collect oxygen. So we're going to do that now. All right, so here is an empty bottle, no oxygen, nice and dry. We didn't use this in our experiment at all. And we're going to take the equivalent of a lighted splint for this as well, basically just a match. A splint is just a piece of wood, so a match, once it's lit and blown out, is effectively a lighted splint, or has been a lighted splint. So here's our match. Blow it out. Put it inside the bottle, see if it relights. As you can imagine, matches don't relight in air, which is probably what you anticipated. So we can show that the presence of pure oxygen is actually quite useful in terms of being able to relight something that's heated. So you need to think about that when you come to answer your questions and actually work through the post-lab questions in this particular experiment. All right, the next part of this lab experiment, what we're going to do is we're going to look at the effect of the time of burning of a candle. So I cut down a little votive candle. So it's a tiny little one. The reason I had to cut it down was because we need to be able to invert one of these jars over the top of it, and they're fairly small necks and probably a bit too small to put over a full-size votive candle. So I'm going to light this candle, and what we're going to do is once it's lit, we're going to take one of these 2 remaining bottles of oxygen, and we're going to time how long it takes for, or how long the candle will burn for. Obviously it needs oxygen to burn, and once you cover it, eventually it's going to run out of oxygen. Now you should do this on a glass plate. I don't really have one handy for this, so I'm just going to do it right on the benchtop here. This one's okay. And then we're going to time it. All right.
My case is off.
So here's our timer right here. So we're just going to invert our bottle of oxygen. And as we do this, you should watch the intensity of the flame as well as we do this. So you're looking for the time before it goes out, and you're also looking at the intensity of the flame at the same time. So here we go. There's a little bit of water around the outside of that, but you can see how bright that is. We're going to start our timer. Sorry, we missed a couple of seconds there. And then we're just going to sit tight until we see that go out. And our, yep, it's officially out, so we can stop it now. And that'll be pretty good estimation of time. So note that down, as that's how long it burned while it was in oxygen. All right, so you have that time. Now we're going to repeat that, but we're going to use our empty bottle that we had over here. And we'll use another votive that I've already cut down. All right, so now we're going to move this one out of the way. And we're going to take our nice empty bottle where we didn't do anything. There's another cut down candle. We'll just make sure it fits under the mouth, and it does. And what we'll do is we'll light that, and then we'll start our timer and see what happens. All right, we'll start the timer there. We'll move the timer a bit more into shot. Sorry, I put the bottle a little bit in front of it. And then we'll wait and see how long that takes. Notice while we're doing this, again, the intensity of the flame. Remember how the last one was compared to this flame? It might be a little hard to see, but the last one was a lot brighter than this one. So it's something you can make a note. So where we had pure oxygen, the flame intensity was a lot different. Actually, I'm going to turn, oh, our candle one already went out after 40 seconds. So I'd say it was about 41 seconds, probably, give or take. But you can make a judgment on your own, play it back in slow-mo, and figure out where you think that went out. So you can see there's a big difference between the jar that had oxygen and the jar that did not have oxygen in terms of what happens to the candle. So last part what we're going to do is we're actually going to take some magnesium, and we're going to catch it on fire using a Bunsen burner. Then we're going to insert it into our last jar of oxygen. And I'm going to turn the light off for this one once I've got the magnesium going, because this is kind of a cool experiment. And I want to make sure we can all see it. But to do this, first thing we need to do is set up our Bunsen burner. So I'm just going to move our reaction out of the way. I'm going to put this in my cleanup spot out of the site. I'm going to grab my Bunsen burner. You'll notice that when I get this, I'm getting the Bunsen burner, I'm getting obviously the lighter, the splint. We could use the matches, of course, that would be a lot easier. Put the hydrogen peroxide out of the way of this, or the rest of my equipment. I also have a little crucible here. The reason for that is when we do this experiment, we want to put the remaining magnesium somewhere, and I want to put it not on the bench because it will actually scorch the bench. So I'm going to have this little crucible that I can place it in when I'm done. So the first thing I need to do, of course, is close off the bottom of the Bunsen, turn on the gas. All right, nice lighted Bunsen burner. We're gonna get a small piece of magnesium. So I have these like old magnesium strips. I'm just gonna cut a piece down using a pair of clippers. You don't need a huge piece for this. If you're pretty strong, you can even like tear it yourself, like that. So what we're gonna do is we're gonna place this piece of magnesium into the Bunsen burner. You'll see it catch light, and then I'm going to immediately hold it inside this last bottle of oxygen. I'm going to bring this just a bit more in the shot. I'm actually going to turn off the light for this one so you can see it better. So you can see the flame here. So we're going to hold it in there for a second. Oh, I'm sorry, we should turn it up a little bit first. So it's pretty bright already. And you can see how bright that got in the oxygen. Oh, I let go of it, so that's okay. But notice what happened as we put that into the oxygen. It got a lot brighter. Hold on 1 second, sorry, my Bunsen's turning. There we go. The whole Bunsen was turning when I was trying to turn it off. So as we added the magnesium into the oxygen, you saw the change in intensity of that light. So kind of as a repeat of what we saw earlier with the lighted splint. When we put a lighted splint in a normal container of air, nothing happened. But we put it in a bottle that had contained pure oxygen, you notice that it had a lot more. And like it relit. So I believe there's still some oxygen left in this. So we're going to try one final test here. And what we're going to do is we're going to actually take a piece of iron wool and we're going to see what happens if we put that in there. So we don't need a big piece of iron wool. Like you don't need like a whole Brillo pad for this. Just a small little piece. And what we're going to do is I'm actually going to slide this under and invert it right away. I still believe there's oxygen in that one. If you'd made an extra bottle of oxygen, you could have done this with that. So I'm going to get the iron wool glowing. Sorry, there was a bit of wax on the end of that. And we're going to try stuffing it in there. And you can see what happens when we put it was just glowing, it wasn't on fire. And you can see the difference in intensity. In fact, if you look very closely, you can see that it's actually on fire and causing sparks in there. And of course, normally in the outside air, that would just die off very quickly. So you can see what happens now. Make your observations. You can explain that in your questions. All right, and at this point, we are done with this experiment. And you can now go get your observations. If you need to go back and replay parts of this to get the necessary observations, you can do that, and then answer any post-lab questions that you might have.